Okay, students. So in this video, we will look at we will recap how we have executed the fourth program of your practical list. The practical list says, write an assembly program to simulate subtract operation on two user-entered numbers. So, as we did in the previous question in the lab, where we added two user-entered numbers, and you can also see it in a video that has been put up for a quick revision for you for question number 3. We will proceed similarly. What we will do is, let me just show you the outline of the program first, okay, through a demo file, okay. So what we do is, let's say there are two numbers, 5 and 3, that we read from the user, and we wish to subtract them. Okay, so we'll first say read. Read was the instruction that I had covered in the last question number 3 as well, right? So we say read. Let me show it to you again. You can see this instruction here, read, right? So machine instruction. Now this is an IO instruction. So see, the only thing we needed to do was that we named the instruction. This is an IO instruction, you can see, right? And we said that we want to read an integer and put it into the accumulator, and the direction should be input. Similarly, later you will see the write instruction. Okay, write instruction. So write does what? Write outputs whatever is the content of the AC on the screen. Okay, so this is the corresponding micro instruction for the write. I have covered it in the question number 3 also. We have just given it some name and some appropriate name, and then we say what kind of data type do we wish to write. So we want to output an integer from what is written in the AC. And what should be the direction this time? It should be the output direction. Okay, so you can see that these are the two instructions. I've recapped it for you. Read. Okay, this is the opcode for read given in your practical list. They have given the name input. I have used read. You can use the name input if you like. This is the opcode given for input. For write, they've given the opcode out, and this is the F400 they've given as the hexadecimal opcode. Okay, so we have used these, and as I explained that these both the IO instructions as well as the register reference instructions do not need to contain the memory reference instruction. So we have used the edit fields. In the edit fields, we've used a 16-bit opcode for them. Okay, so this is it. So only this is required for read, and then we say end. And for write, you can see the other instruction in which the direction was reversed, that is, it was output, right? So this is it. So when we say read, what happens is whatever we put in, whatever the user puts in, it goes into the accumulator. So you can see, so suppose the user has put in 5. So AC will now contain 5. Now, in this program, instead of the variable sum, we have declared a variable diff to store the difference of the two numbers. I have declared it similarly as we declared sum. So diff followed by a colon dot data to 0, which means that diff will be a data variable which should occupy 2 bytes. Please allocate 2 bytes for it in the main memory and give it an initial value of 0. Okay, so diff contains initial value of 0. So when we read a number, it goes to the AC automatically, right? And suppose the user has given 5, AC will contain 5, but the diff will continue to contain 0. Then we say store diff, that this store instruction is the same as the STA instruction. Okay, uh, here you can see your STA instruction, right? So I showed this instruction also to you yesterday. Let me go over it once again. So what do we wish to do here? We just want to store whatever is this address or variable name. Okay, we just want to store whatever is written there in store whatever is written in the AC to this particular address. Okay, so this means STA store AC into diff. Okay, that means whatever is stored right now in AC, please store it at diff. Okay, so how to implement this? I'm going to be showing you this load, store and load instructions. Okay, I'm recapping these both for you. So store is the equivalent of STA and load is the equivalent of LDA. You can see LDA here, right? Now, so how will these work? Please see. So store and load, both of them are memory reference instructions. So we are using the fields OP and address, 4-bit opcode and 12-bit address for them. Okay. And the first thing obviously that we do in any memory reference instruction is that we transfer its address from the 4 to 15th bit of the instruction register into the memory address register. Go to that location in the main memory and transfer the contents into the MDR. Okay. Now, if the instruction is store, then what we do, since we have to store the contents of AC to that address, so we've transferred that address into MAR and we transfer the content of AC to data register, and then this content is written on the address which is now contained in the main memory. Okay, now in load, however, we do just the opposite. So LDA means load into AC whatever is written in the address that we are transferring into MAR. So we go to the MAR, and that is the main memory at this address, transfer whatever is written into the data register, and then transfer it to the AC. Okay, so so we've read the first number, okay, 5, okay, and stored it into diff now. Okay, when I say store diff means whatever is stored in the AC, please store it in the variable diff. So diff now should have 5. Now we read the next number, okay, and now what do we want to do? We want to subtract these two numbers. When I say read, what happens is that AC will now contain 3, whereas diff continues to contain 5. Okay, now when we say subtract diff after this, what happens? AC is equal to AC minus diff. Okay, the only thing is that I have written diff minus AC here. That means when you please see, when you implement the minus subtraction instruction here, right? Just remember to put the source 1 as the data register and not accumulator. Okay, otherwise what will happen? You can see here. Otherwise, you will get 3 minus 5 is equal to minus 2. But since the first number was 5, which was stored in diff, which we had already stored in diff, and you want to subtract the second number from it, that is why we are selecting source 1 as the diff, which we will be storing in the data register, okay? And we are subtracting AC from diff. Is this clear? So please take your source 1 to be MDR, okay, and source 2 to be AC. Okay, the destination is again AC. The destination is again AC, right? So after this, AC will contain the value 2, 5 minus, because 5 minus 3 is 2, but diff still continues to store the value 5, which is theoretically not right. So we will again do STA diff, that is on my machine I've named this STA as store. So I'll be saying store diff, and so that this value of AC gets stored in the variable diff, and then I say write. So it will write the value of AC here. Okay, so this should be the output. Now let us see. This is the difference that I was telling you. If you choose source 1 as AC, then this is what will happen, right? Now let us just execute this program and see. Okay, I'm putting this in debug mode so you can see it step by step. So let's assemble and load. So you can see that this address 18, no, 16 has been assigned to diff. Okay, okay, let's start. So the first instruction is read. It is asking me for a number, right? I've entered 5. So you can see 5 here in AC, but the diff is still 0, right? Then we say store diff. So you can see that 5 is now stored here. Then I say read, next number. AC now contains 3, whereas diff contains 5. Then we say subtract diff. Okay, so you can see that 5 minus 3, AC now contains 2. I want to store this difference now here. So I'm saying store diff. So you can see 2 here, right? And then I'll say load diff. That means please load this difference into the AC so that in the next step I can write it. So this has been loaded into AC and now we are writing, and this is the output. Okay, we stop. This is question number 4 for you.